Hello guys, this is the MEPtutor, and in today's video I'll be solving this problem. We have this circuit and we have three capacitors with three capacitance C1, C2, C3. We have a power supply E and everything is connected as shown in the diagram. The question is to find the total capacitance and charge on the capacitors and the voltage and charge on each capacitor. First, we observe that capacitor 1 and capacitor 2 are in parallel, because if the current flows in this side, at this point, it will have to divide into two currents. And when that happens, the capacitors are in parallel. So we'll have a capacitor here that is equivalent to the other two capacitors. It's called capacitor 1, 2. And capacitor 1, 2 will be equal to the sum of capacitor 1 plus capacitor 2. Then this one will be in series with capacitor 3. So we will have a total capacitor here, let's call it C1, 2, 3, or the total capacitance of the circuit. This capacitance, this total capacitance will be equal to the inverse of capacitor 1 to C1 plus C2, C2 plus the inverse of the other capacitance. Capacitor is 1 over C3. Everything to the minus 1. And this will be equal to C1 plus C3 times, C1 plus C2 times C3, and here C1 plus C2 plus C3, everything to the minus 1. And we just inverse that and we get that the total capacitance of a circuit is C1 plus C2 multiplying C3 over C1 plus C2 plus C3. We also know that the formula indicates this. The capacitance is equal to the charge over the voltage. If we are looking for the total charge, we can clear this variable. Charge is equal to the capacitance times the voltage, right? So let's do that. This will be the total charge. The total charge QT is equal to the voltage U, the total voltage, multiplying the total capacitance. C1 plus C2 times C3 over C1 plus C2 plus C3. And now the letter A of the problem is solved. Let's continue. We're looking for the voltage and charge on each of the capacitors. We know this is data, that if we have two capacitors, let's call, and they are in series, capacitors in series, let's write it like this, series. Then, if we have two of them, the charge of the combined of two will be equal to the charge 1 and equal to the charge 2. and the voltage 1, 2 will be equal to the sum of voltage 1 plus voltage 2. If capacitors are in parallel, then the opposite will happen. The charge 1, 2 will be equal to the charge 1 plus the charge 2. And the voltage 1, 2 will be equal to the voltage 1 and the voltage 2. So the situation at the beginning is the next one. We have C1 is in series with C3. So if they're in series, that means that the total charge, let's write it in blue, the total charge, because they're in series, will be equal to the charge of C1, 2, and equal to the charge in Q3. Alright? So Q3 is this. And the voltage, the total voltage will be equal to the voltage 1, 2 plus the voltage in 3. But we know that we can also put in this equation to have the equivalence that voltage is equal to charge over capacitance. That means that we can find the value of the voltage 3. The voltage 3 will be equal to the charge in the capacitor 3, which is equal to the charge in the total charge over the capacitance in the capacitor 3. So let's write that. Capacitor 3 and the total charge is U C3 times C1 plus C2 over C1 plus C2 plus C3 and everything divided by the capacitor 3. Let's write like this, and this will be eliminated this. And this will be equal to voltage C1 plus C2 over C1 plus C2 plus C3. Using this information, we can replace it here and clear the variable that we are looking for. In this case, the voltage 1, 2 in this capacitor. The voltage in this capacitor will be the total voltage minus the voltage in 3. Let's write that. This will be equal to U minus U times C1 plus C2 over C1 plus C2 plus C3. Sorry, this is not dividing. I mean, it's like to be correct in the representation will be like C1 plus C2 plus C3. And this is equal to U C1 plus C2 plus C3 minus U C1 plus C2. Everything over C1 plus C2 plus C3. So the voltage in U12 will be equal to UC3. This is eliminated over C1 plus C2 plus C3. All right. What else? We know that C1 and C2 are in parallel. What does that mean? That means that this U2 will be equal to the voltage in 1 and the voltage in 2. So we all have now all the voltage. So we are only left with the charge in 1, because we also have the charge in 3. So we got the voltage in 3, voltage in 1, voltage in 2. We'll have charge 3. So we only have to find charge 1 and charge 2. And the charge, we already used the formula, that is the capacitance times the voltage. So this will be basically the voltage UC3 over C1 plus C2 plus C3 times the capacitance. The capacitance of capacitor 1 is C1. And the same process with the charge 2, which will be equal to voltage C3, but in this case will be the capacitance 2 over C1 plus C2 plus C3. And that's, my friends, it's all the problem. Thanks for your time.